And then we start to share screen. Share screen. Let's see. So maybe first let's do this part. Yesterday I forgot to mention. You remember for this hold on, let me do for this tree graph. Is it? This is hold on. Why I cannot write? Okay, for this tree graph, is it? And this is the decision tree. This is generated generate for that iris example. Is it iris that example? That example we do the classify. Is it classification of 3 different flowers? Is it Setoso, versicolor, and virginica, etc. And for the decision tree, we already know it's do the split. Is it based on the selected feature? Is it doing split? And if so, like in this case, this is so you have 35 samples. And all 35 samples go to the first class. So Setosa, etc. So then this is pure. That so no more splits need anymore. So this leaf node is pure, is it? And you can also see it entropy, is it? So it's also 0, is it? And if it's not this case, like for this case, then you still need to do a split, is it? And then we can generate this tree, is it? So I forgot to mention the example how this tree is generated, okay? So let's go back to the code. Hold on, let me find my code. Yeah. Okay, then over here. Okay, so for the so when you do the decision tree training, is it the training? And one of the important feature for decision tree is it's transparent. Is it? It's transparency. Transparency, is it? And we can also see a lot of internal decisions, is it? So you want to see the tree, is it? So over here, for this part on my class notes, that example notes, and I also put you need to install this pipe dot package. Okay, so here I also list the steps to install this. And you install this, and you also need to install the GraphViz, okay? And then you also need to put it in certain environment paths, okay? So anyway, in my notes, I put the detailed instruction here. And after you install the package, and if you do want to get that graph, okay, you need to import the graph from data module. You also need to import the export GraphViz model, okay? After that, then you can do the export GraphViz, okay? And this tree, this is our decision tree. That decision tree model that we trained. Okay. And you set fill, so it will fill so each of the nodes is there. So here the nodes is fill, and you want its color, like our diagram show, it's kind of rounded, etc. And you also need to make sure to put the class name, etc. So we have this 3 class name and the feature names. Okay, feature names. And this is for output file, and by default it's none, okay, because over here we are going to export it, okay, and then you can, and then that you can get the graph, okay, get the graph to a file name. Is it? So here we save it to a PNG file, okay, and then you can view that PNG file. So this is a whole step how to export your decision tree, okay. And yesterday I forgot to mention this. And then next we are going to start with a leftover contents. Okay, so over here, we have another concept, and in machine learning, you also see this a lot, okay? And so yesterday, what we learned is a single decision tree, okay, single decision tree to do the classification. And you can also, like over here, combine multiple decision trees on the same data together, okay? So then we call it a random forest. So random forest is also a module, okay? So what is, it's kind of like over here, it's an ensemble of decision trees. So it's multiple decision trees together, is it? Because yesterday, you remember, we also, when we discussed the information gain, is it? And for information gain, you remember, we have the case A, is it? And the case B, is it? So because each time when you pick the node to do the split, is it? You try to do what? To maximize the information gain to do the split. But it's also based on the feature you select, is it? So the tree can form differently, is it? Differently. Differently, and if you combine all these different cases together, is it? So that's why here's we can get ensemble of decision trees, is it? For the same data set, is it? To do training, is it? And then in this case called a random forest. Okay, random forest. So here it says the idea behind the random forest is what? Is you average multiple trees, okay, and for each single decision tree, for the decision tree, is it? We also learned decision tree. It's good, is it? But its downside is to what? It may have high variance, is it? And who still remember a high variance can easy to introduce what? To make your model what? With high variance, make your model what? Tend to what? We said there are two kinds of fit. Who still remember the two kinds of fit? So high variance,
overfit and underfit.
Yeah, very good. It's so in decision tree has the downside is make model tend to overfit. Okay, tend to overfit. And overfit generally caused by what? It's by high variance. Is it? High variance can introduce overfit. Is it? For underfit, underfit is what? It's a high what? So fill blank. So who still remember? We call it bias. Is it a high bias? Maybe you pick too few features. Is it? Or maybe you don't have enough samples. Is it? So So that's called a higher bias, is it? But this is the high variance. So overfit means what? Means for train. So training model fits very well. Is it? But when you have a new data, then the performance degrade. Is it? Performance degrade. So that's called overfitting. Is it? You don't want that happen. But decision tree, when you do training, is it? It can give you very good performance. Is it? But when you have new data, then it may degrade. Is it? So we don't want that to happen. So here it says to build a more robust model that have better generalization performance. Is it? And less susceptible to overfitting. Is it? Then the random forest can help this in this regarding. Okay, so that's the idea about random forest. Okay, so anyway, random forest is just multiple trees together, is it? Okay, random forest, the algorithm here to summarize the steps. Okay, so it's not a very comprehensive one. Okay, so the first thing is you draw some random bootstrap sample of size n. Okay, and normally you pick the same size of your original data set, okay? But over here is you allow replacement, okay? So that means some sample may be allowed to be repeated, okay, in your training data set. So this is the first, you just pick some random size of samples, okay? And then what you do, you grow a decision tree using your picked samples, okay? And at each node, what we are going to do over this time is different from the general decision tree, is that you random select D features, okay, but without replacement, okay? You random select it, and then you split the node using the feature. So using the feature that you select, okay, and you do the best split according to the maximizing the information gain, etc. So for each of the tree, so over here says repeat this two step k times. So k times means we are going to have k single decision tree. Okay, so for each decision tree, you're going to do this two step. So you draw some random samples, okay, and with replacement, so you allow some sample be repeated, okay, and then you're not going to select all of the, you just select D features, okay, and based on that feature, you do split. Okay, you do split, grow the decision tree. Then in this case, you're going to have, if you repeat k time, you're going to have k decision trees, is it? And after that, you are going to aggregate the prediction by each tree to assign the class label by majority vote. Okay, suppose you have 25 decision trees, as if for this random forest. Is it? And then each tree, when you have a model, is it? It will make a decision. Is it either 1 or 0? Is it? Predict. So here is that majority vote. Is it? So when you do prediction, if majority of the 25 are 1, then you say, okay, the classification, the class is 1. Otherwise, it is 0. Okay, so that's what it means, majority vote. It doesn't mean all 25 need to predict the same result. Okay, no. So you just aggregate and then with the majority vote. Okay, and here is a combined multiple decision tree via random forest, is it? So random forest, because you conglomerate multiple trees, is it? And of course, the decision trees advantage of the interpretability, you cannot get the same level interpretability, is it? So it's not as clear because it's from different trees, is it? And for random forest, big advantage here says you don't need to worry about choosing hyperparameter values. So you don't need to worry this a lot. And also you don't need to prune random forest tree. And for decision tree, you remember so it has a correlation between the performance and the depth of the tree, is it? Of course, the deeper, the better, is it? But sometimes too deep can also cause overfitting, is it? So anyway, over here, we don't need to prune the random forest tree, okay? And the number of the trees also here is important. So there is a trade-off, is it? Of course, the larger number of the trees, the better the performance is going to be, is it? But you have increased computation cost, is it? So this is very nature, is it? And generally speaking, for the sample bootstrap sample size, normally you keep as original, the size n. And the number of features, is it? What we choose is, we choose the square root, okay? So if you have, so for the sklearn, okay, from that package, generally speaking, the number of features for each individual tree in random forest case, it chooses the square root of the number of the features of the training set, okay? So this is the general idea about a random forest. So it's pretty straightforward, okay? And next, let's take a look the example, okay? Okay, so over here. And then, so for the random forest, okay, we still do the same on our iris data this time. We use random forest, okay? And if you take a look, the random forest, it's from the ensemble, okay? And you import the random forest classify module, is it? And over here, this criteria, this is similar, as for information gain, is it? For the impurity, is it calculation, is it? So here, you remember yesterday we said there are 3 ways, is there 3 different approaches. So Gini is one, is it? And we also have entropy and classification error. So Gini is one, is it? So here it says, okay, I'm going to use Gini, is it, for information gain calculation. And the N estimators, this is the number of the trees for your random forest, okay? Random state, we already know, is it? It's allow your a model to be reproducible, is it? With the same data, so reproducible. Is it? And here, the jobs. Okay, you can also specify the jobs. So because here we have random forest, is it? So it uses multiple single decision tree. Is it? Multiple single decision trees. Is it? And so you can, to expedite, to speed up the processing, is that we can allow parallel processing. Is it? So if you said, okay, n job equals 2, then you allow, if your computer has multi-core, is it, to do the parallel calculation. Okay, so this is what this parameter means. And here we didn't specify another parameter, maximum features. Okay, so by default it's auto, and auto is a square of the features. Okay, we already see that. And after you create this model, and then you can do train with the training data, is it? And after you do the training data, and then you can do the testing, is it? And the prediction. And over here, what it's going to do is it's going to draw for the samples, is it's going to draw the decision boundary, okay? And we can see the result is pretty good, is it? And yesterday, if you recall, you can also, for decision tree, is it? Yesterday we learned. So decision tree model, is it? And one of its use. So one of its use is what? Is to do feature selection, is it? Feature engineering. That's also a topic in machine learning, is that you select a feature, you want to filter out the noise feature, is it? So over here for random forest, you can also see the importance of the features, is it? So you can get the model, and with this feature importance parameter, is it? And then you can see their score, is it? The percentage row it plays, is it? So here we use a loop, is it? Loop through each feature's importance, is it? And because over here we only have 2 features, is it? Pedal length, and the pedal width. So this is the first feature, 0. This is the second feature, is it? 1. So we have these 2 features, is it? So you can have these 2 features. And here we also do a bar drawing to show, is it? And we also get their specific score, is it? And for the random forest, you can see it's different from our decision tree, is it? For the random forest, it looks like a pedal width. Oh no, pedal length. So the row is a little bit of more important. So it's tilted a little bit of more to pedal length, is it? Because it's 52%. And the other feature is just 47%, is it? Because if you take a look of yesterday's, you remember for yesterday's, for this is a model for, yeah, we use Gini, we also use entropy, is it? And then we have their feature importance, is it? Then in this case, you remember the pedal width plays more important role, is it? So here it just shows the you can also collect the feature importance, okay, from your model after you train the model. Okay, so basically that's all of the information, okay, information. And Sean post a chat in our in the group chat. So anyone you interested in checking with him, please check with the chat, okay. So that's all for today. So